Hello everyone. Today we'll explore the realm of noise diagnosis in turbo machines. We'll discuss how to diagnose common conditions by analyzing noise spectrum. Let's begin with an overview of noise interpretation or noise diagnosis. The table highlights the type of faults that can be detected through vibration measurements. Each fault can be identified by examining the frequency spectra and orbit shapes. We've also provided corrective actions on the right for your reference. Now let's dive into the topic of mass imbalance. Mass imbalance in a rotor results from an uneven distribution of mass causing the rotor to vibrate. This manifests as a 1x frequency spectrum. You can address the mass imbalance by performing field or shop rotor balancing. It is essential to adhere to industry balancing standards such as ISO, API, and others. These standards detail the acceptable levels of remaining imbalance. API standards are more stringent than ISO G2.5 specifications. The primary goal is to minimize the force due to center of mass. Some turbo machines use ISO-spec to define the allowable imbalance in the machine, and the parts are balanced accordingly. The acceptable imbalance can be defined based on the factors like rotor weight, machine speed, and the desired imbalance grade. This example here uses ISO G2.5 grade. For more detailed explanation of how to use ISO-spec to define the imbalances, please refer to Part 6 video. Here is an example of 70 megawatt gas turbine balance plane. 3 different planes are utilized for balancing. In essence, mass is either added or removed to minimize forces due to center of mass. Part 24 video offers comprehensive guidance on rectifying imbalance. Machine can subject it to significant wear and tear over time and can experience an increasing in 1x vibration due to mass imbalance. If the vibration increases too much, parts may need replacement and field balancing may be required. Let's return to the table for a moment. Now let's explore the topic of misalignment. Misalignment between the bearings, shaft, and rotor can lead to 2x noise. Additionally, coupling or machine misalignment can also induce 2x noise. The presence of 1x is due to imbalance, but in misalignment cases, 2x can reach similar amplitude as the 1x's. The orbit shape resembles a figure 8. What is meant by orbit motion? When you measure a rotor motion using 2 sensors, the orbit shape is typically circular in the case of imbalance. However, with the misalignment, the orbit shape resembles a figure 8. Here is an example of actual measurements that exhibit this figure 8 pattern. So it is important to monitor the shaft vibration because it helps to diagnose the machine symptom before they get worse. Bentley, Nevada provides detailed instruction on sensor installation in your machine, which is crucial for understanding the machine behavior and vibration over time. Bentley, Nevada recommends using 2 vibration transducers for radial vibration measurements. These transducers should be mounted coplanar and 90 degrees apart within the 3 inches of the bearing, and this is for large compressors. The XY configuration provides comprehensive view of shaft centerline vibration and radial position within the bearing clearance. The probes should be mounted nearly perpendicular to the shaft centerline within an angular separation of 90 degrees plus minus 5 degrees. For integral geared compressor, a single probe per bearing is acceptable when the space constraints prevents the XY configuration. To protect against thrust bearing failure, it's crucial to use 2 thrust probes for redundancy. And a spare probe with an extension cable is recommended for internal mounting arrangement. The position measurements should be taken at the thrust-bearing end of the machine and within the 12 inches of the thrust bearing to account for thermal expansion effects on the shafts. Mounting thrust probes directly through the thrust bearing is preferred, but when not possible, they can be engineered to observe the end of the shaft through other color within the similar proximity to the thrust bearing. Here is a vibration instrumentation diagram for centrifugal compressors. The shaft radial vibrations are measured at both left and right bearings. The axial thrust position measurements are also required at the thrust bearing location. Lastly, temperature probes are installed to monitor temperatures. A similar approach applies to axial flow compressors with shaft radial vibration measured at both left and right bearings. The axial position measurements are also crucial at the thrust bearing location. Also, temperature probes are installed to measure temperatures. For this geared compressor, there are 6 bearing supports, each equipped with displacement sensors to monitor the machine vibration, and temperature probes to monitor the machine temperatures. So we touched on sensor installation in your machine. Now let's revisit this table. Today we covered mass imbalance and misalignment, as well as where sensors should be installed in various machines to monitor machine vibration and diagnose its condition over time. In the next video, we'll delve into the remaining noise issues in the machine. Thanks for watching, and I'll see you in the next videos.